I'm really honored to have some of the sharpest AI minds in the Seattle area on our panel today. And so I'm going to invite them up on stage in a bit and briefly introduce them. But first, just to get a sense of the audience here, how many of you have a primarily business function? All right, it's about half of you. How many of you are actually into code? All right, also almost half. And how many of you happen to know what an AI transformer is? Okay, also about half. All right, good. So we will cover the next 3 years of AI. We will keep it fairly technical, but also try to make it accessible to a business audience. So for the business people in the room, hopefully you'll get an appreciation of the terminology and the big picture view of AI. For the technical folks in the room, hopefully you'll have a roadmap for the next 3 years, or kind of a high-level map of the AI space for the next 3 years. And so as events, both predictable and unpredictable, unfold, you have a frame of reference to pin them in. But without further ado, let me invite our panel up on stage. All right, thank you. And by way of introduction, we have Nitin Agrawal, Corporate Vice President at Microsoft, responsible for Microsoft Copilot, Search, and MSAI. Enough said. Nitin, great to have you.
Thank you very much, sir. Thank you.
We have Praveen Seshadri, co-founder and CEO of Thought.ai, an enterprise AI startup transforming the future of work. That sounds good to hear. He's had a distinguished career at Microsoft and Google, as well as other startups. We have Yifan Zhang, the co-managing director of AI2 Incubator, a serial entrepreneur yourself, started Loftium and Gimpact, founder and CEO. As you all know, AI2 is a major force in the Seattle area in terms of AI entrepreneurship and startups, incubating the next wave of startups. And we'll have Yifan talk about that towards the end. We have Joseph Sirosh, the CEO and founder of cutting-edge startup Creators AGI. Building a marketplace of AI agents. Joseph's a career AI leader, Amazon, Microsoft, Compass.
Thank you.
And then we have Ece Kamar, VP of Research and Managing Director of the AI Frontiers Lab at Microsoft. Ece's group is very interesting, cutting-edge research on the future of AI, so she'll have a lot to say today as well.
Thank you.
Great. Welcome. So kicking us off here, we will focus primarily on the next 3 years of AI. But we'll start off with sort of some big picture vision. Before we get to that, let's do a quick lightning round. I'm going to ask the panelists for their view individually on the most exciting or meaningful AI innovation to come out in 2025, 2026, 2027. So let's start with 2025. start over with AJ.
Okay, I'm the first one. In some
Because
ways,
you have the next 10 years laid out. Just
oh
ask
yes,
me
I
for
do.
3.
Yes, I do. You know, like thinking about time in this AI space is so difficult because in the research space, we spend a lot of days saying, oh, do you remember that thing that happened like 2 years ago? And you realize that it was just 6 months ago. It's just the time is morphing, the horizons are collapsing. So, and one thing I'm seeing is that the kind of the differentiation between the horizons between research and product development is really collapsing now. Everything is very fluid. Okay, I have the hard task of doing this prediction. The first one is an easy one for me because my lab does a lot of work on agents. So my first prediction is going to be that this year is going to be all about agents. And in particular, I think we are going to go from AI systems that are producing language to AI systems that are doing things in the world, that are taking action. And I think that's going to be an important leap that we are going to be learning a lot from. The second prediction, do you want me to continue for the next 3 years? Or do year by year?
Let's do year by year.
Okay, I'll stop there.
Yes, and it's okay to have overlap, of course, etc.
And what I have to say will be probably similar, but I do think 25 is when we nail reasoning. And I think we will have reasoning models, both large and small. There will be small reasoning models, for example. I think one of the small reasoning models is about to come up, O3 Mini. And I think that's a big deal. I mean, having large reasoning models and small reasoning models are very, very interesting.
I'm going to be the practical person,
Yeah.
aiming for the business side of the teams. So
Practical innovation is the only one that matters at the end of the day.
that's true, although the research is really exciting right now as well. So the tool that I'm really excited about is Bolt, and I think 2025 is going to be the year of the no-code software development finally happening. For the folks that are on the business side, I think we're starting to see the magic of these tools in a way that the engineers probably got to see with Cursor and previous tools.
Great. Praveen?
I think the first half of 2025, the trough of disillusionment with AI is going to deepen, while the marketing efforts are going to spin harder and harder. In the first half of 2025, I expect the trough of disillusionment to deepen in terms of there's all this promise but not delivered. And in the second half of 2025, I expect on the business front, agents will start to deliver value.
Nitin?
Yeah, I guess I think Joseph said what I was going to say as well, that 2025, the models are going to become smarter, not just bigger, but they're going to get into reasoning. Like instead of just producing the text, they're going to tell me how should I think about solving a problem. And then I also feel that in 2025, AI is going to reach to that scale. Like if you look at the last couple of years, we went from hype to doom. And I think this year is going to get normalized, which means more people will just accept that AI is there to help them instead of getting scared or too excited about it.
All right, 26. And
Okay.
ideally, one word or one piece of innovation.
For 2026, I'm predicting new ecosystems.
Computer use becomes real.
Great.
Generalist browser agents.
Intelligent physical robots.
I guess a lot has been already said. I was going to say robot as well. I think new businesses, not just these large 7 companies that are making use of AI, but the ground up innovation, which like the way cloud did, the AI should enable that as well in 2026.
Yeah. And then 27.
I think we are going to figure out continual learning for AI.
27, you can actually buy an embodied intelligence, a robot, Optimus, maybe.
I think point solution robots. I'm kind of more pessimistic, just point solutions.
All right.
2027.
All right.
I mean, I think maybe just build on top of the robot theme. Like I remember there was a video I was watching in some All-In podcast. My son was watching that and said, "Dad, this is amazing. I think you should just buy that for me." It was $16,000. I want to play pickleball with that. And I think I'm not going to pay $16,000 today, but maybe in 3 years it's going to become cheap enough that I will probably buy a robot like that for these small tasks.
Great. So what you're hearing is a lot of different themes, a lot of innovation, many different dimensions. And hopefully our discussion over the next hour or so is going to help frame all of that, or much of that. So you have sort of a lay of the land picture. Let's then, so in terms of the flow over the next hour. Yeah. Yes, that should work. Yeah. So we'll first set the very big picture stage, zooming right out, kind of 100-year view, very briefly, and then we'll talk about some fundamental scaling limits that current AI has been running into, and then we'll talk about the technologies that are going to get us to break through those scaling limits. And we're going to frame those technologies. We're going to use a very interesting use case, computer use, that's mentioned among the predictions here. We're going to use that as an anchor use case that ties together most of these innovations that are going to help us break through scaling limits. And computer use, the fundamental use case, is really going to change the nature of work in fundamental ways. So that's a great use case to work with, to put these things in context. And finally, we're going to end with, what about AI perpetuating AI and improving itself? And finally, Yifan's going to bring us home. What does this all mean for startups and entrepreneurs? So that's sort of the rough map. So let's zoom out 100,000 feet. Where is AI going? So we have some near-term milestones. There's artificial general intelligence, AGI. There's artificial, and we're going to have the panelists sort of take a crack at defining what that means for them. Then there's artificial superintelligence. That's when AI sort of exceeds human level performance. And again, we'll try to get a little more specific. Beyond that, things get fascinating and interesting. And just as a brief trailer, the briefest of trailers, you have something expected called AI takeoff, where AI is so self-perpetuating that it essentially becomes an entity that's more powerful than sort of human intelligence, even perhaps collectively. And beyond that, you have even more exotic terrain. Get into, by one account, von Neumann machines tapping into the cosmic endowment. We're definitely not going to be talking about that. Maybe that's a 100-year project, but that's it's a big picture. And along there you have really interesting questions of control and values and so on and so forth. So for the most part, we're not going to be talking about that stuff today. We're going to be talking about the next 3 years. The near-term technical roadmap. So let's start with AGI and ASI. Those are interesting, even the next 3 years. So let me ask, Joseph, your company, Creators AGI, I would think has a little to do with AGI. How would you define AGI? And actually, can you explain the connection as well? And do you think we'll get there in the next 3 years?
Yeah, thank you for the question. By the way, Creators AGI, the AGI in that is a bit of a play on the words. I originally thought of AGI in that context as authentic generative interaction. And why I named it that is that I believe that in the future, you would have AIs that are actually communicating. I mean, we will be communicating with AIs. Everything will be represented by AI. I believe AI is a new medium of its own. So just like when the printing press gave rise to books as a medium, or in the invention of radio gave rise to radio shows as a medium, I believe AI actually creates a new medium. And you will be communicating in new ways with AI. Knowledge will be represented for AI to communicate. And AI is multimodal, right? It's not just text or chat. It can talk to you. It can visually express itself. It can generate any type of content. So you are actually seeing the birth of a new medium. It's not talked about that much, but I believe that as a company, I can build a platform for AI to be a new medium, and that's why I built Creators AGI. But then stepping back into AGI itself, by the way, maybe the simple definition is when this panel on the next 3 years in AI can all be run by an AI, right? So that's AGI. Another way you could think about it is when most people, or a majority of informed people, will agree that you can get most work done just by calling an API or talking to a robot. You don't need humans anymore. And that's a very simple definition of AGI when you can get there. Now, it takes a lot to get there, but like Sam Altman is saying, I think artificial superintelligence is likely to be there before AGI, the general intelligence. Partly, I believe, and I would love to hear from the other panelists as well, is because in certain domains, like coding, for example, you have very high quality data that is both generatable and verifiable. Because you write a piece of code, you can actually run it through an interpreter and verify. And so you can essentially create unlimited amounts of code, so to speak. And then high quality code to learn from is easier to get. It's a contained thing. So wherever there's a possibility of generating extremely high quality data that's also verifiable, and you can have really good feedback to align models and reason with, well, then you have the opportunity to be super intelligent. And so artificial superintelligence in specific domains can advance dramatically faster than areas where you just don't have data. And by the way, even the reasoning models of today, I believe, are limited in part, and you would probably know a lot more, by the lack of thoughts, right? They're supposed to be aligned with how you actually approach solving a problem, the thought process of actually creating them. Crawling the internet doesn't really give you thoughts of how people approach solving problems, but you need a tremendous amount of data. Ideally, you would have a tremendous amount of the data, and that would be what makes a model intelligent. But in certain domains, you can acquire that, and therefore ASI is likely to move much faster. Would love to hear from you, AJ.
There is really a question about what motivates our field. Because people throw a lot of these abbreviations of ASI, AGI, but at the end of the day, what motivates me as a researcher is getting things done and providing real, true value to users at the end of the day. Because I find some of these notions kind of misleading, because when we take something like superintelligence, we actually had narrow superintelligence in AI even 25 years ago with Google. The way Google could process information, not with these large models, but just being able to process it, was so much better than any human could do alone. So it has been achievable that we get to superintelligence in narrow domains, and that's why I think the notion that matters more for me is it generalizable? Is it able to learn? Is it able to improve itself in time? And in fact, when we go back to the definition of AGI, one of the things there is continual learning, not being a static learner. In fact, in the world, we wouldn't call something intelligent if it is making the same mistake many, many times without learning from that experience. And that is something we are currently lacking from any system, any major system that we have in the world. So I believe we are making significant advances, but a lot of the signals we are looking at, Joseph, are exactly the things you're saying, where validation is easy, ground truth is easy, and we are kind of picking our favorite domains of math and coding, where we really, really understand the domain very much. But to be a true generalist that is providing real value, I think there are a few other big problems that we will need to solve as a community, not only like showing the masterful skills on math or coding.
Great. So it sounds like that domain specificity is important to one interpretation of the definition, but the ability to learn is super important to another definition, another interpretation of definition. Do you believe, AJ, we will get to AGI in the learning sense in the next 3 years?
Again, it really depends on the definition. I personally don't think that we are going to have a fully generalist system in 2 years, but we are going to be seeing major advances that will pave the way for it. But I think, I'm just thinking, like we were just talking about this before the panel. It is 2.5 years since GPT-4 came into the world. And again, it is all about timelines and how fast we expect some things to happen. But when I had GPT-4 in my hands as like an early user, before there was even a ChatGPT in the world, maybe Nitin will remember that experience at Microsoft. And we wrote the Sparks of AGI paper. I don't know if any one of you have read that paper. We had huge expectations about, like, if you asked me that day, like, given that you have GPT-4 right now in the summer of 2022, where we would be in the winter of 2025? I'm a bit disappointed as the industry. So I think it is just important to really calibrate expectations. Some things are going faster than we think they are. But I think in terms of getting to that real usage, to changing lives, making AI indispensable in our daily lives, I think we have been going slower than I thought we would be.
Okay, that's a great lead into the next topic, scaling. So as you were alluding to, OpenAI is taking a long time to work on its next version, GPT-5 Orion, with being at it for at least 18 months, if not longer. And with each training run taking 6 months plus and $500 million plus, and results seem rather modest. Can you talk, AJ, I'm going to start with you, about the scaling laws, the power laws that impact model performance and how that is contributing to the slowdown?
To answer this question, we may need to go back to 2014, 2015, when ImageNet came out to be and people started really training some of these models at larger scale than just toy problems. And what we have been observing in the research community for the last decade is that at every generation of the model, based on the transformer architecture, as we double up the size of the data, and accordingly we throw more compute to the model, we have been able to see some new unexpected capabilities come out of the models. And this was most evident, this jump was most evident with the GPT-3 to GPT-4, where GPT-3 was it was called in the research community at the time stochastic parrots. Like, this is something that is just able to predict the next word in a way a stochastic parrot would do. That was kind of one of the coined terms. And when the scale was increased for the creation of GPT-4, we turned a stochastic parrot turning into a pretty good reasoner. And in fact, many of the panelists talked about reasoning, and what is really special about reasoning is that it is not only memorizing information, but it is learning patterns of problem solving that can be thrown into unseen problems. And that is what is super interesting about the frontier models that has been coming up since GPT-4. So there is really like one of the biggest questions in the research community. We just came out of NeurEPS, which is getting larger and larger as the conference, and everybody was talking about this is, do we expect this exponential curve to continue? as both the size of the data and size of the compute increases for the next generation of the models. And mainly the question is that what are new capabilities that will be unlocked and how existing capabilities are going to be improving as we scale the models further and further. So as you said, we haven't seen a GPT-5 yet, but there are many organizations now building these frontier models. And what we are seeing is that scale is no longer about the size of the pre-trained model, but it is also about the compute that goes into the different stages of training that happens around the models. So some of the most recent advances has been about something that is called the inference time compute, where the idea is that, yes, I have the model, it's already trained, but I can run the model in interesting configurations at inference time, make the model question itself, verify its correctness, try the problem multiple times, just spend more time thinking about it. And through that, I can actually improve the performance and solve harder and harder problems, because you can even see this thinking trace, like the thought and the logic processing as the model does this. So one of the things that has been interesting is how we think about scale. It's not only about the size of the pre-trained model, but what comes afterwards. And these post-processing steps and inference time becomes more data for training other models that can create kind of a feedback loop. The last thing I'll say about the scale is that one of the things I believe that has been really interesting in the AI community is, yes, I may need scale for proving the existence of a new frontier model, but I may not need the same scale to replicate that again and again. And this really matters for the competing factors in the community and kind of the economy at scale of these models. So when you have the existence of a model like GPT-4, let's say, yes, I may need a lot of compute to get to that model, but then I might be able to distill information from such models, train something much smaller, and match the performance. In fact, this is an idea that my lab at Microsoft has been pushing forward a lot. If any one of you heard about the Phi models, we just released Phi-4 before the winter break. This is what the idea has been all along. Not because necessarily we thought it was the most interesting research idea, but we had no compute in the company, so we had to come up with a creative way of doing something new. And the idea there was like, how can we put the most capabilities into something really, really small? And the Phi family of models and the SLM wave that has been happening since then proves that scale might be really important for discovering something new, but it may not be a fundamental ingredient for having those capabilities in future systems, which matters a lot because as we are trying to get AI to be at scale, it gives us more efficiency, and it may even allow us to put these systems onto devices.
Thanks, Ece. So as Ece's alluded to, the traditional way of scaling large language models, so GPT-1, GPT-2, GPT-3, that's essentially breaking. That mode of increasing model size 10 to 100x, feeding it 10 to 100x more data, etc., running 10 to 100x more compute on it, that is not yielding more returns. And so AJ just talked about a couple of techniques that are going to be fundamental over the next couple years to take AI to the next level.
May I jump in with just an observation?
Yeah.
Can I ask a question of the audience? If you set aside ChatGPT, how many of you, could you raise your hand if you are, in the last 6 months, you have utilized the latest, or whatever AI is available with the latest models, etc., and improved your work 20%?
You said outside ChatGPT?
Outside ChatGPT. Okay. Outside, okay. So that's less than half the audience. Okay. And how much work did you have to do that? Can somebody say, I used AI and it was done for me in a day? Can somebody raise their hand and say that?
The question's right.
Oh, and I got that 20% improvement in some of my work in less than a day of effort putting it in. putting in to build this stuff. Okay, 1, 2, 3. And so I'll just make that observation as, to me, that's the scale problem, which is that for all the benefits and amazingness and superness of AI, that either philosophically or from a technology point of view sounds wonderful, this is the group of people, tech savvy in a tech savvy city, who are interested enough to come to an AI event in the evening. And so there's a huge scale problem in terms of actually being able to apply any of this to make our lives better. And the set of things needed to make that happen somehow are lacking enough investment or breakthroughs or ideas to actually put it to work. So that's a sort of a different dimension, I believe.
Thanks, Praveen. And
I'm really curious, what do you think is causing that? Like, what's blocking that impact?
Okay. In my mind, OpenAI is the truly innovative company in the space. No offense to my to the VPs flanking us from Microsoft.
We're friends.
I think
And all of us have some Microsoft DNA in us in this room. So, but OpenAI blew our minds and reset expectations, and everybody else has followed. And the last time they blew our minds was around with ChatGPT. And then there's been some people blowing our minds around content with images and video. And we're waiting to have our minds blown around productivity. And the fact of the matter is, sticking to an ancient format of Outlook, Hotmail, Gmail, whatever, and your file system, which still looks like papers in a folder. And that ancient format from the 90s has to be blown up and disrupted in an AI way, and then we're going to get productivity, and somebody's going to come along to make that happen. That's my belief.
And so that's a perfect segue, Praveen. I'm going to turn to Nitin to talk about
Maybe I was going
computers.
to say something different. I think one of the reasons for that is our lack of ability to unlearn what we have learned over the years. Like, for example, at Microsoft, we are supposed to be the leader in AI, but not every engineer is using the GitHub Copilot because people think that they are a better coder than the AI, right? Like just yesterday, my team developed this thing called Copilot, and we are supposed to do that at work. But just yesterday, somebody told me that I could use that to rewrite my Connect. I never thought about doing that. I thought Connect is the Microsoft review tool that we do. If I'm a manager, I'm writing that for my employees. If I'm an employee, I'm submitting that to my manager. I could have done that. I could have saved so many hours, but I'm just used to doing what I was doing before. So lack of imagination, lack of awareness of what you can do with this tool, that's blocking that scale as well.
And so Nitin, can you talk to computer use as a scenario and how your efforts there are taking the whole way of doing work into a new era?
And I'm assuming when you say computer use, you're talking about the KUA model, the computer using agent. Is that what you're thinking?
Yes,
Yeah.
yes.
Yeah. I think it's still in the early stages.
Microsoft 365 Copilot.
Yeah. So I'm not going to talk about the actual details of the project we are working on.
Yeah.
But I think at a high level, we do believe that, you were asking about what's going to happen in 25, 26. If you had asked me 27, I would have said in 27, we are going to have an AI model where I'm going to tell the system, let's say if I'm a support agent, I'm going to tell the model that just parse the screen, and based on that screen, take the data from app 1 to app 2 and then complete the task in app 3. Where I'm not connecting the data, I'm parsing the screen. I'm looking at the pixels on the screen, extracting the data and doing that, which we all do today as humans. So basically, I believe that in the next 2 years, the world of customer support agent is going to be dramatically different. Computer using the models, the KUA models are going to change that. We are going to have these large models, multi-model, which are going to look at my pixels, extract the text and images, make sense out of it, monitor a human's behavior, quickly learn from that by just observing their behavior for 10 minutes, that when you are trying to resolve a ticket, these are the 7 things that you do in 5 different apps and 7 different tools. That is going to happen. And Microsoft is operating in that space. We are innovating, we are experimenting, still in the early stages. But we believe that in the context of Windows and M365, we are going to do some of these things. It's going to take a while.
May I do a build on that? I mean, Anthropic today has a demo where you can screenshot and actually drive actions on it, right? I actually think of computer use in a more ambitious way as well, which is, hey, if you're sitting in front of a computer, you're actually also learning through that computer, right? So you can go to a website, figure out what to do on that website, absorb information, knowledge, reason with it. And even AJ spoke about learning being an important thing about an AI, right? In context learning, so to speak. But a computer use agent that can actually, through the computer, access the world of the internet, can actually interact with entirely new websites it encounters. Maybe it'll pick up Angry Birds online and play Angry Birds for fun. I don't know. I mean, it could be doing that. But an agent that's actually capable of interacting with the online world and using it, I think that is possible in 2026, in my opinion. And it'll be enabled by several things, not only hosted models like OpenAI or Anthropic, but NVIDIA, I don't know if you saw, released a $3,000 PC. Lenovo announced they would have a Blackwell card in a PC in the second half of this year. They announced it. It's a B200, and it's an amazing fact that you can have that. So when you have the ability to have reasoning models running on a computer, and by the way, here's the importance of small reasoning models. There are some people who believe that a reasoning-only model that doesn't have to have a lot of knowledge, that's capable of learning, maybe only 1 billion parameters, not a trillion parameters. But you should probably speak to that. I don't know what the size of a reasoning-only engine is. If that can run locally on a machine and it can access the internet and can use it, it would be incredibly exciting.
Yeah, I definitely agree. I think for my 2026 prediction is generalist browser agents. And I really appreciate the answers around kind of what's blocking adoption of AI. That's something we think a lot about as an investor in AI. I would have said, actually, I think prior to this year, right, I think AI usage was much more about co-pilots, right? It required a human in the loop, which meant, what's the difference between a co-pilot and an agent? An agent is able to take action because we actually trust the decisions that the AI is making enough that we are able to hand over control completely to that agent. I don't think we've been there yet, right? So the human in the loop co-pilot model means that you're not going to 100% be able to get rid of a human and get like 100% productivity gain. So, for me, in looking at computer use, I think this is a very interesting space. We actually have two investments in this space, one that's short-term focused and one that's much more long-term focused. Our long-term focus play is a stealth research-based investment, and I very much believe that someone's going to crack it. Probably multiple people are going to crack native understanding, right, of browsers, of images, of the web in the way that a human does when browsing the web. So we also have an investment in that realm. The shorter-term play for us is much less ambitious. I think today, when we think about a non-technical audience, for example, professional services, lawyers, financial advisors, folks that do not know how to code, we really need to think about code generation and writing connections between existing tools, right? So we have an investment in a company called Caddy that actually allows lawyers and financial advisors to screen record everything that they're doing. And the AI is able to natively understand that screen recording, the context behind that, write deterministic code that then connects the tools that they're using and automate the workflow in that way. So nowhere as ambitious as these native browser agents, right? I think that will take a couple of years for us to get there. But we like to think about, okay, well, we're not there yet technically. What can we do today to deliver immediate value so that we can, acquire customers, gain revenue traction, and be able to raise further resources for our startups?
If I may respond to a few things the panelists said, It is important to understand what capabilities are needed to be able to unlock a scenario like the computer use agents. One of them is perception. Be able to look at an interface I'm looking at right now and being able to extract the information from it in terms of what are the actions? Is there a text box? Is there something clickable here? What can I do? And getting into the size of the models, we have actually trained a model that was 3.8 billion parameters in size to do that problem really well. The harder problem, which connects to why advances in reasoning is going to matter so much, is being able to get an intent, something that we want to get done, and be able to decompose it into atomic actions and do this reliably and safely. I think that's going to be the real challenge, but I think the advances in reasoning that's happening with O1, O3, and other models is going to be really an important part of solving this problem. But the one thing I'll say, I really believe that in a year or two, we are going to have these agents working on our computers. We are going to figure that out. But I'm also expecting, if we are making predictions today, that we are going to be seeing some disastrous-like scenarios happening as well. Because there is something fundamentally different about a system that's able to take actions rather than just producing code or language. The thing about actions is that unless you are taking those actions in a sandbox, you may not be able to revert those actions back. If all of the agents in the world that is produced by a company decides to buy the same flight ticket in the next half an hour, that really means that the rest of the population will not be able to buy those tickets. And the other thing that's really interesting about agents is that now that the reasoning power is going up, and they can understand that, yes, my user wants me to accomplish this, and I'm going to be doing it autonomously, not in the co-pilot mode, they can get quite creative about doing it in ways that a human, a user, or even the enterprise may not imagine that it was possible. Just the other day, some of the agents we are developing in my lab tried to change my password because I gave them a task. They went to the website. There was a pop-up asking for credentials. The agents did not know the credentials, but there was a link there that said, you can reset the password. It is possible. There is nothing now that says that you cannot do it. We still don't know what is okay for an agent to do or not, right? So we are going to be getting into these discussions, these spaces where we have to figure out what is okay for an agent to do. How do we build systems where we can take things back? And how do we think about all the things that may go wrong when these agents are going to be multiplied and they are going to be communicating and sharing recipes of doing things so that a failure can actually be just more than one agent failing, but it can be more of a system-wide thing.
I don't want an agent to take over my Robinhood account and do all the trading for me. By the way, one other interesting thing that intersects with a lot of these is just yesterday, maybe early today, have you heard of this Minimax 01 model? Amazing, 4 million context window, 1 million output token generation capability. That 1 million token generation capability blew my mind because Claude is 4K, Gemini is 8K, GPT-4 I think is 16K, but O1 can actually generate a little bit more. But when you can actually generate 1 million tokens as an output and then feed it to the next step of reasoning, think AutoGen or any of those, and you can actually keep that. I mean, that's incredible because one model is able to communicate a tremendous amount of reasoning and number of steps and planning and context and all of that to another step later. And that next step itself can hold 4 million in its mind and then, reason with that. So who knows where this is going to be. It's going to be really, really exciting. And by the way, if any of you want to try it out, Minimax 01, it's a very impressive paper as well. It's actually available. That's the thing. It is open source. It's available on Open Router. If you have an API key to Open Router, which you can sign up now if you want it, you could try that model. But it goes back to some of the things that Others have been saying, we don't know what to do with these models yet.
Can I build upon this?
That's a big gap. Go ahead.
So can I build upon what you're saying, Joseph? There's a tendency to describe a model, describe the stuff as, wow, the AI is so powerful because I gave it a very unspecified open-ended problem, and it demonstrated reasoning because it went and explored a space. Sometimes I heard the new OpenAI model took 20 minutes to do it, explored all kinds of possibilities, came up with its own unique way of solving a problem. Uniqueness is viewed as a sign of intelligence, figured it out itself. True. On the other hand, if you look at practical work, do we hire, suppose a new person joined your team, do you give them a partially specified problem with no guidance on what to do, be unique about solving it in any possible way, and be impressed when 80% of the time it does it wonderfully? How does it matter what it did the remaining 20% of the time? That's kind of a strange view of intelligence. And I bring this up because sort of, if you look at the practical world of applying AI to work, there's two kinds of tasks that get assigned. One is the ad hoc task. Man, I gotta go book this business trip spanning all these different places, and I gotta schedule all this stuff. Can you help me with it? It's a one-off task. It's very different from, I've gotta do a customer service process, or I've gotta do a sales process, and I've gotta follow some rules and so on. In that second category, a huge output token limit is often a bad idea, because the more stuff each little step of AI reasoning produces, the more opportunity for something that isn't quite right. There's more to check. There's more to actually make sure it is what you wanted it to do. And so this notion of reliable and repeatable work that conforms to work intent, business intent, is an important area that doesn't fall out of, I give it a prompt, it went off for 20 minutes and came back with something, but it requires more thinking like, what's an AI programming model to put together structured intent that then AI can follow, and how do you have frameworks and infrastructure that ensures that it follows and executes an intent. So that's a space for, I am able to articulate this now, I couldn't a year ago, because that's a space we're in with thought.ai, but that's sort of what we're discovering is we don't need models with huge outputs and complex things. You almost want to break the problem into smaller, simpler things that even us humans can reason about what they're doing and check that they're right.
And
But let me actually ask one question though, Praveen. Do you think that is going to be an enduring issue, or each year models and their output will become dramatically more reliable?
So I can only fall back on what I know, and to the extent that AI, even in our definitions of it, is intelligent like human beings are intelligent, and that AI is learning from the information that human beings give it. As long as AI lives in that world, in that we're trying to have it behave the way humans did and take instructions the way humans take it, etc. What I said is actually reasonably true of human beings also with junior folks. You want to give them some guidance, people join your team, you want them to follow rules, you have to comply, you've got policies, all of this stuff is true. Maybe in one of those worlds, that you were talking about, Sonu, where there's a takeoff and cosmic AI or whatever, where the rules change, then, I'd have retired by then, so what do I know?
I think I would say that the repeatability is a bit overrated in my mind. Like, let's say if you ask me a question today and you ask me the same question a week later, I don't think I'm going to give you exactly the same answer. Maybe it's probably going to be about the same, but my articulation will be different, the choice of words will be different. So I think these large language models, they are stochastic and they are not going to be repeatable. Like the search index, when you and I were working on the search index,
right,
I think the humans are going to accept it in my mind.
Yeah, but I'm a bit surprised you're saying this, because it's not about the syntactically is it repeatable, but semantically is it consistent and repeatable is important. Because if you are willing to throw, let's say you're a bank, you're accepting some, you're vetting some applications, a human would read it and you want AI to read it instead. And there's some policies to follow. you have all kinds of issues, legal and otherwise, if you start doing inconsistent things. And so consistency and repeatability is important, and explainability of it. And that's one of the big issues that businesses are struggling with right now. And the fact that a newer model will come out with a few more billion parameters doesn't fundamentally change that, right?
No, I think that's right, and I think that's the reason that co-pilot versus autopilot discussion that we were having is important. Like that's the reason today, majority of the experiences are co-pilot-like experiences. So for example, the one place where I rely on AI very heavily, like there's a meeting happening in an hour, I'm actually not gonna go to that meeting, and I will not have a fear of missing out. Because there is an AI representing me in that meeting, collecting information on my behalf. I'm gonna show up in the morning and just ask the system, just generate the insight, and then action items. Did anybody even say my name and all of those things? I think that's a place where repeatability is not that important. And I will catch up. It's fine. But yes, if there is a place where the Robin Hood thing that Joseph was talking about, that is very important. The repeatability is very important for that one.
Oh, I just don't necessarily want repeatability. I just wanted to make money.
You just want accuracy. You just want accuracy.
And so with the computer use scenario we've been discussing and the various offshoots of that, as we've talked about, and AJ and other panelists alluded to various elements of what makes a computer use scenario tick. It's large multimodal models that you talked about. It's action models, so having an action view of the world and of tokens and next token generation, and reasoning, and agentic workflows. These are the foundational AI capabilities that are going to power the next generation of AI innovation in the next couple of years. I'm going to take us to the future of AI coding. There's a very tantalizing near to midterm prospect is AI leveraging itself to improve itself. And so I'm going to ask our panel here, how far might AI go in the next 3 years with AI writing software to improve itself? Joseph, I'll start with you.
Oh, thank you. So I think let me go to the question of AI self-improving. I think if you think about what makes AI improve today and what are the bottlenecks in that, it's really the human innovation of a few researchers, maybe some in your team, with a massive amount of compute and data, of course, right? It's obvious. But the huge bottlenecks in setting up experiments, managing these gigantic clusters, organizing the data. I mean, the amount of incredible grunt work in babysitting one of these large, especially if you're innovating on the model, it's just mind-blowing. I think the vast majority of people don't understand how painful this kind of experimentation is. And I'm not just talking about just the training, it's pre-training, post-training, all kinds of things. It's just incredibly painful. And of course, the human alignment data that's required, lots of people manually creating it. Now, of course, reasoning models creating data, many, many more things. And so in the next small number of years, I think coding agents can help alleviate a lot of this heavy lifting, making the entire process of innovating on AI itself a lot less burdensome. And I think that's amplifying a small number of incredibly capable human beings on the planet who are just creating the next models of the future. And I think that's what the short term of improvement is going to be. It's not necessarily self-improvement, it's incredibly, it's assisting the research itself. By the way, you'll see that in all scientific fields as well. I think at the cutting edge of science. I am myself on the board of a company called Absci that's creating new antibodies with AI. And essentially, they're creating new antibodies with AI. and they're inventing sequences of antibodies that will dock into an antigen and using AI-based in silico experiments. They are going to be amplified in their efforts by coding agents and so on. And so there's a very virtuous flywheel that's happening now between the researchers and the AI. In fact, many scientific fields are taking advantage of that. Very few people fully see the cutting edge there. By the way, much of astronomy had already gone, observational astronomy had already gone to machine learning before a lot of these things, and many astronomers are absolutely processing everything with machine learning. So I think that flywheel is happening in a big way. But maybe you can build upon a little bit of how AI is enabling, or coding is enabling AI researchers themselves.
Coding is a really special domain when we think about it, and I actually think that application of AI models and systems to programming is almost like an early indication of what is to come in many other application domains. And there are multiple reasons for that, because the input and output language of programming is text, and text is where a lot of this revolution started from. And the language of programming is very suitable for what these LLMs are learning about. So that's one, why this is kind of an easier domain to master and produce value. The second one is that the definition of correctness is objective, and we already have tools in place in programming that can, compile the code, that can run tests, that can do some of the checks. And the subjectivity is mostly out of the equation. The third thing I'll say about programming is that the context you need to be able to solve a problem is pretty contained inside a whatever IDE you are familiar of using. So those are all things that simplify the value generation question we've been talking about in that particular domain, and that's why mastering things there gives us clues about how to do things in harder domains, where things are more subjective, where there could be more ambiguity, where the context is more distributed. When I think about the problems Nitin is talking about, like it's all distributed towards a graph and a network rather than being really embedded in the repo. So I think we are figuring out like what are those things that needs to be unlocked, so that the success we are seeing in programming can be adapted to many other domains. But the last thing I'll say about this is that we have been also vague about what we are calling AI in this conversation. Sometimes we are calling AI to mean a model. Sometimes we are calling it to be, something that has RAG and context around it so that there's some form of learning happening. And sometimes we are using AI to mean a full stack where we are putting in memory, we are putting in action, we are putting in context, we are using orchestration in it. And I believe a lot of what we are going to be seeing in the next few years is going to be bringing ideas from other areas of computer science into this stack, not only focus on how to make the models better, but also bring new ideas from compilers, from verification, from software engineering, and all of it to really understand what is that future stack that will bring us reliability when we want, repetitivity when we want, depending on the different use cases, providing us the criteria that we want to see in that application.
Will AutoGen 0.5 be written by AutoGen?
My team builds AutoGen, and we have been learning a lot about how people are building agents thanks to it. I think the next play we are going to do is going to be about ecosystems, Joseph.
I'll just add, I think we've talked a little bit about the disappointments of AI, but I think from the coding perspective, this speed of adoption and progress has really exceeded, I think, anyone's expectations of, what AI can do in code. And the 2025 prediction, right? Mine is around no-code software development, and I think it's not even 2025. Like it's already happened. For anyone who's not technical in the audience, I would highly suggest that you try Bolt. Bolt is essentially a coding agent. You're able to just use natural language and allow Bolt to write all of your code in a browser. It downloads a bunch of your packages. If it runs into errors, it tries to self-correct its own code. And for me, I think, like it's still very much in the early stages. But if you think about Cursor and where that was 2 years ago, right? Like most of the engineers using Cursor at that point, it only worked on 20% of your code. And yeah, it was still so effective and powerful that people stuck with it. And now at this point, right, it's writing like 80% plus of people's code. For me, I think something like Bolt is pulling back coding at a research level or at a machine learning, model level. Most of the code that we write is pretty simple, right? It's building websites, it's building workflows, it's integrating APIs. I think that type of software development and the ability for normal everyday people who don't have software engineering skills to be able to build those things themselves, I'm hugely bullish and excited to see what happens from that perspective. And I think this year we're going to see a lot of interesting development in that area.
And Yifan, why Bolt versus V0?
I think Bolt is even friendlier for non-technical folks.
Yeah.
Vercel, it's still great, but it requires a little bit more expertise, right? Bolt, I think it's helpful if you can read the code that it generates, but for someone like me, I've only coded non-production things, like just for myself, right? I cannot build anything at scale. I felt like Bolt was the first time that I could actually just use natural language, make tiny edits in the code myself, but most of it was done by the agent itself.
Right.
I have an interesting, for me, it's sort of interesting to hear the conversation, partly because, okay, fine, I've coded as my primary job for more than 35 years, that dates me. But also, I spent a decade building a no-code app platform company. And so when I started that, I got very much into the religion of no code is the way to go. So I completely concur on that front. And you can use an intelligent system to help transform intent at a high level into something that will run the intent. That said, and as I started out with, I spent all this time in my life writing code. Code is an incredibly inefficient way to capture intent. And we are forced to write this complex beast. The generation of it is the easiest part. It's the maintenance of it, the understanding of it, the debugging of it, and explaining it to the next person who comes along, and all of the pain in the ass that happens after the first code's written. That is super expensive, and we're forced to do it because that's the only possible way to get this computer to do your bidding. And you can do only certain things with it, which are deterministic things, more or less. And the world is already, through the brute force of all of us programmers, programmed many of these deterministic things. So now along comes a technology that can use these computers to go after the not so deterministic things, the subjective things, using intelligence. My analogy is, we've been building homes with stone and brick, and along comes vibranium. Black Panther, right? Along comes vibranium, this wonder new material. So in the short term, in the first year of access to it, we say, let's use vibranium to produce more stone and more brick and build homes the same way. And I think that's what we're doing at the moment. We're saying, we got this army of programmers. They're the most expensive employees on the planet. Let's make them more productive by using the AI to spit out the code they would have written anyway. Right? But I think if you fast forward a little bit, I actually suspect we've got to bypass that code to higher level representation, more intent or natural language representation that AI interprets at runtime rather than translating into code that's in this hard-coded lockdown. And I'm pretty sure a controversial subject, but
yeah, and for me, I think it's about time frame, right? Like, what time frame are we talking about? How good is AI going to be in that vision? And even at that point, I think I would still question, right? Like we were talking about workflows. Like there are some things where deterministic code maybe is more useful than just having everything be generative AI. Like for example, we have another investment, Friday Harbor, that's a mortgage underwriting company, right? So at the beginning when they're building this company, there's a lot of excitement around engineers, like to use everything has to be Gen AI, everything has to be created from scratch. And it turns out to be actually quite inefficient because there's a lot of things, especially in mortgage, it's spelled out, it is deterministic, right? There's rules that can be followed and it's not the right tool, right? You don't use the same tool to do every single problem. So I agree, I think we're probably over or underutilizing, right, the tool right now because of limitations. But I'm not sure if in the future everything is going to be Gen AI or needs to be.
And on that note, Yifan, sort of bringing us home for the panel portion before we turn over to Q&A, can you talk about where is VC investment expected over the next couple of years? What does all of what we've been discussing mean for the entrepreneurs in the room?
Yeah, obviously this is just one person's opinion. There's many different opinions in the VC community. Kind of pulling it way back, we are an incubator, right? So we work with founders at the very, very early stages, pre-seed and earlier. And I think for us, we are looking for areas of defensibility where companies will take like 5-10 years to build. So it's such a rapidly moving environment. How do you find defensibility today? Especially when there's folks in the room talking about the major advances, right, that are going to happen in the underlying models and technology. Like I think of those as almost like dinosaur feet coming from above and kind of tromping on different areas and industries. And we've seen over the past 2 years, right, a lot of, especially horizontal dev tools, that arena has been very difficult to build because of the instability of the underlying infrastructure and technology. At the same time, right, a lot of these tools also enable, right, if you have an idea, now 1,000 other people might have that same idea and compete with you. So then at the end of the day, it's not a technical moat, you're really competing based on go-to-market, based on sales and marketing. And for technical folks, like that might also be very uncomfortable. So, where do we go, right? Dinosaur feet from above, 1,000 competitors from below, like every 19-year-old can build the same thing that you're building. For us, for the past year plus, we have been focused on vertical AI, vertical application layer. And I think that's quite surprising for AI2 Incubator, and that's not how we've always thought about AI investment. I think nowadays, when I speak to VCs, vertical application is like exactly what people are investing in, but we were doing it since probably mid-2023. And the reason why we do that is, one, I think with vertical applications, if the horizontal tools underlying everything, right, can achieve, say, 70% of where things need to be in order for a customer to pay for it, there will probably be advancements from 70% to 80% to 85%. But there will be industries where the requirement is 90, 95% or above. And by focusing on the vertical layer, you're able to really bridge that gap and offer additional value that then you can capture and have customers pay for and create a bit more of a moat around that. And when we talk about vertical, we also haven't been focused on just classic B2B SaaS, right? B2B SaaS has been, in some ways, a bloodbath for VC investment because so many things have taken years for companies to build now can be built very easily. We are actually focusing in more non-traditional industries that maybe haven't received as much investment before. So we're talking manufacturing, compliance, mortgage, right, professional services, legal. A lot of these industries require a certain amount of expertise to build the right product, right, to bridge that 85 to 97% gap, right? You really need to know what the industry needs, what it doesn't need, and you might also have a certain amount of expertise around connections and sales that prevents, the 19-year-old that can build the same product from penetrating the market as quickly as you can. So for us, that's been a thesis that has paid pretty well for us as a fund over the last 2 years, and Sonia's a LP in the fund, so has some insights on that. We had some major exits in the legal tech and in the tax tax, accounting industries in the last year. So we're continuing to focus on that. I do think, this discussion was really exciting to hear, especially your comments around, compute and resources might be changing in terms of the next level models. And we are starting to look into some of that as well. So I'm hopeful that the next generation takes a bit less resources and we can find those areas where it is possible, right, to make startup level investments and create new products. But for now, I'll just leave you guys with, I tend to look for areas where the customer expectation is still quite low. Instead of looking for areas like, I'm a consumer founder. I founded 2 consumer companies. I made 0 consumer AI bets because I think consumers have probably some of the highest expectations of anyone, right? Around latency, around experience, around like cost, right? They're not willing to pay anything. So I tend to look for areas where the expectations are a bit lower and it's feasible for us to be able to hit those expectations today and then build upon it as the underlying technology gets better.
One comment though, that it does seem like a very defensive strategy. So the world is changing so much. Maybe this is the area where I can actually preserve my LP's money. Feels like what you just said.
Yeah. And I guess passion. There has to be passion. You can't just force your way into loving mortgage.
Because all the big companies in computing, are horizontal platform companies, right? And there are very few big computing technology companies that are vertical.
But on the other hand, it does seem AI too has done fantastically well with its vertical strategy, right?
Yeah, and it's a very specific part of the VC stack, right? If I'm like Tiger, right, investing $100 million at once, I might not take this strategy. But for the early stage, and assuming that folks here are interested in starting companies and starting at the early stage, I think that's an area that we found to be much more protective for founders.
Going back to the domain of programming just for a second, I think that's a domain that shows the value of creating new experiences, taking risks in terms of how you build the experience, and also not relying on only having the best model. And I think that domain expertise, like conversion of a domain expertise to the right experience, is gonna matter a lot for who is gonna win in these spaces. For example, Microsoft was first with the GitHub Copilot. Cursor is a startup, right? I think that dynamic has been really interesting to see in terms of what matters for the user at the end of the day. I'm not saying that's gonna be the case for every application, but the fact that now you can actually choose whatever model, but what really dominates in that particular application domain is the experience of the user, I think tells us something about what needs to happen in other cases as well.
Fascinating.
One comment, obviously I'm not a VC, but there's a third startup I'm in, and I'm learning this time around that there's a few things that are weird and different about this moment or the last year or so. The first thing is usually if you're doing a startup, the big players are often asleep at the wheel. That gives you some breathing room and a chance to make some progress, engage with some customers. You got some differentiated offering, and whether it is Google or Microsoft or whatever, they're not paying attention because they're shipping Windows or Office or whatever Microsoft used to do, right? But now, damn it, these guys are they've taken 100,000 people, and there's honest people, and they're all doing the same thing you're trying to do. So that's sort of weird. Even though they will spend a month on what was it, the review, what was that you called it? Connect. So maybe that time you can,
Now we'll spend only a few days.
Now the AIs will write the Connect and read them, and yeah.
I will write it, AI will read it. I also write code.
Yeah, I will handle the bonus. But anyway, so there's that part of it. But the other side of it is that the market, customers are completely confused. They're confused by Copilot, they're confused by AGI, they're confused by everything. And it's not like they're all locked into any solution. Just because they got a Microsoft license in the past meant they can't touch you. But now it doesn't mean that. Microsoft or Google or whatever. So as a startup, you have this sort of dual thing of if you can acquire customers with something interesting, there's an opportunity. But everybody else in the world, whether they are big companies, startups, all supremely funded and are all trying to do something too. So it sure feels like a gold rush, super confusing, and all the rules are going to be different. Whatever we learned about B2B SaaS, not true. Whatever we learned about pricing, not true. So I'm just sort of focused on the B2B world a bit because that's what I understand. I never understood the consumer world, and whatever people knew about the consumer world, that's not true either. So it's, I would say, exciting and all of that, but very difficult to be prescriptive about here's a path to follow or here's the approach. I find the VCs, as an observer talking to them, did a bunch of crazy things in the last 2 years, and I paid the price for it. They threw large sums of money at whoever had traction in a month, and lost the money. And so they're also learning because things are moving too fast. So it absolutely feels like gold rush, and maybe some of those old sell the shovels rather than, maybe some of that's true, I don't know.
All right, so on that gold rush note, we'll support the panel discussion, and we do have a couple minutes for Q&A. All right.
I have a question about humans and employment. So let's set aside coding. Coding is going to get overtaken, it's already getting overtaken and all of that. AI is going to eventually take up a lot of jobs from humans. So my question to you guys is anybody thinking about what are humans going to do? Yuval Noah Harari had a pretty interesting answer to that question. Homogeneous, if you guys read it. But I'm curious, are there new answers? Is there new thinking around it? And that has impact on government policy.
That has impact on government policy, that has impact on how states, local governments, and employers and capitalists are going to have to behave, because you need to keep humans motivated, engaged, and so on.
I'll start off for the panel to see if anyone has anything to add. I think it's an area of great unknowns. In past waves of major technology revolution, there's always been this upskilling. So the fact that agriculture is completely mechanized only increased world GDP and efficiency, and those who farm are now doing generally much more interesting things. With AI, as we get to ASI, it is completely unknown where human upskilling opportunities might lie. We know for sure that humans will always have a preference for other humans for certain aspects of their lives. It's a human service. AI can never replace some aspects of human service. So there will always be some value for humans to add. But how exactly upskilling works is all
So I have actually a simple answer to it. As humans will use AI to invent new jobs.
So I'm not as optimistic as you are on that topic for a number of reasons. One is, when I look into the investments into infrastructure and AI and how costly it is, and I look at where possible revenue may come from, I'm finding a lot of those, and I'm curious about your thoughts, particularly on this, around business automation. Taking workflows that are done by people, vendors in businesses, and how those are going to be automated. And I'm worried that we might see that effect really early, especially the predictions we made at the beginning of the panel. I'm not saying any plan about what's going to happen to those people. And in fact, when we talk to economists, there's a lot of yes, this has happened in the past, and every generation finds new ways, upskilling, or, we've come up with new creative new jobs. I hope so. That would be great. At the same time, what happens to the current generation that we are living through right now? And I'm not finding the answer that, yes, we are going to find something to do in 1 or 2 generations really compelling, because I'm living through this generation. This is what matters for me and my children right now. So, coming to your question, I'm expecting that we are going to be seeing some effects pretty quickly, especially for value-defined workflows and business automation. And I'm curious, maybe you are seeing something, but I'm not really seeing some proactive efforts to really think about what's going to happen to our generation.
Yeah. I have a perspective which comes from, as I mentioned, I built a no-code startup as part of that. And one of the things I observed is we have a sort of a first world version of this problem, I think, which is, hey, a job I'm secure in may go away because of business automation. And in some sense with thought.ai, we're allowing businesses to automate things with AI. We may enable some of that. On the other hand, in many places in the last 20 years, democratized technology has been a tremendous tool for people to grow their lives, get out of drudgery, do creative things, grow businesses, and so on. So the technologies that were self-service, comprehensible, and usable, whether you think of WhatsApp or even a simple spreadsheet or communication mechanisms, ability to put up a web page, these things have been transformative and positive. So I think that making AI self-service usable such that people can use AI to get stuff done that otherwise they couldn't do is going to be something that grows opportunity and gives people the ability to do things and make things happen that drive their benefit. And from the work and business point of view, it generates revenue and money and all those things. So it's not all black and white as far as I see.
I mean, I'm an optimist on this one, so I'm not I know Yuval Harari has a very negative point of view in his book, but I'm a very optimist. Maybe I'll give you some of the cliched answer that I'm sure when the last time the horse carriages were replaced by the motor car, somebody must have asked the same question. What are all these humans going to do? But I'm pretty sure we figured out something better to do. I also believe that, I think I was reading some research that was claiming that the last time the world's productivity improved is when Microsoft introduced Office and PC. I don't know whether it's true or not. Microsoft. Yes, exactly. So it's a very biased view. And again, like I said, it's not a fact, it's an opinion. But, so I believe that the AI is going to increase the world's productivity and maybe the world's GDP as well. I did see a curve, I remember in some research that says that if you look at the curve of GDP growth over the last 100 years, it is sort of flat or growing at a very slow rate. Maybe this is the time when we're going to increase the world GDP at a faster pace. And then, of course, humans will then try to go figure out what other planets we should go live on. And if nothing else, we'll have Candy Crush. We'll go play that.
All right. I know there's lots of questions, but we're at time. We do have another half hour of networking here, so until 8:30. So feel free to come up, ask questions of the panelists, etc. But just want to be respectful of the panelists' time and commitment and so on, and your time. So thank you.
Thank you all.
First of all, thank you all very much for staying and listening. Awesome panel, really. I mean, I thought that this was just so wonderful that not only were you answering questions, talking about a vision, talking about the future, but you were also challenging each other. So I thought that was actually very interesting, and you were looking at it from very different perspectives, from research, from business, from large businesses, small businesses, humanistic perspective. So thank you all very much. For Ty, again, we're very delighted that we can host some of these events. We welcome you to join us for our next session, which will be in May. Thank you all very much, and for the panelists for taking your time and being here this evening. And Sonu, fabulous job.